Hello and thank you for visiting the Danfoss Video Network. Today we're going to look at the replacement of an expansion device on an indoor residential air conditioning unit. Prior to starting, we ask the homeowner to clear away the vegetation surrounding the outdoor unit. This will allow for better airflow through the condenser, and at the same time it will keep the coil clean from dirt and debris. The net result is lower condensing pressures as the unit doesn't need to work as hard to reject heat, and that means substantial cost savings and energy usage for the owner. Once the power is secured and checked with a voltmeter, we will reclaim the refrigerant charge from the system. In this case, this is necessary as we'll also be replacing the compressor. To see more of this, refer to our video on replacing a scroll compressor on an outdoor residential air conditioning unit. If this was not the case, the system could be pumped down into the condenser, and only the residual refrigerant from the indoor coil would have to be reclaimed. It is mandatory to remove the refrigerant from both sides of the system. Remember, never mix different refrigerants together in the same reclaim tank. To avoid that possibility, our technician is using a single-use type reclaim cylinder. To determine how much refrigerant has been removed from the system, weigh the empty reclaim tank, and then weigh it once again after the reclaiming process is complete. If using a standard reclaim tank, the refrigerant can be reused provided care has been taken to ensure it is not mixed and if the system originally contained the correct charge. Here our technician is checking the pressure remaining in the system with a manifold gauge, while making sure that the reclaim unit is isolated. It's recommended that the filter dryer also be replaced while the system is already open. This process is shown being completed in the scroll replacement video. Once the reclamation of the refrigerant is complete, the removal of the current expansion device can begin. When removing the covered panel from the indoor unit, it's important to avoid damaging the condensate draining line and any other connections that may be routed to it. In this example, the technician has discovered that the condensate line was cross-threaded at the drain pan and must be removed. Using a hacksaw, he removes the damaged section. Once the cover is off, the A coil can be inspected. Take care to look for dirt and debris, especially pet hair, which can severely block airflow and reduce heat transfer. Also, look for excess corrosion on the frame around the U-bends and damage to the coil fins. It's helpful to take a minute and determine what the replacement of the existing metering device will entail. Here, the technician inspects the existing setup, including the valve type and location, the location of the external equalization line, as well as where the sensing bulb is located. Make note of any possible problem areas that could influence the performance of the metering device. To uninstall the existing metering device, remove the connections from the liquid inlet as well as the valve outlet to the distributor. When removing the old valve, it's a good idea to limit the torque on the tubing and other fittings by using 2 wrenches and applying force in the opposite direction to each other. Remove the sensing bulb and bulb strap. If desired, the old bulb strap can be reused to save time if it's not damaged. Once the existing metering device has been removed, check the system fitting types and select matching fittings from the TR6 kit. Each Danfoss TR6 valve comes with a parts kit that includes Chatliff and Aeroquip connectors, a sensing bulb strap, as well as a length of foam tape for insulating the sensing bulb. The kit provides the technician with all the components necessary to install the valve in a single package, eliminating any extra trips to the truck or a wholesaler to pick up any fittings that may be required to meet an unexpected need. Pre-fit the valve to make sure that there will be no issues with tolerances, connection sizes, or damage to the connectors which could interrupt the brazing process. It's much easier to identify these issues before you have a lit torch in your hand. When it's time to use the torch, it's imperative to check the regulator or regulators to ensure that the gas pressures are at the required level and that the regulators are not damaged or loose. In this instance, our technician is utilizing an oxyacetylene torch. Make sure the tip that is on the torch is the correct size for the tubing and fittings that you're brazing. Also, it's a good idea to have a properly rated fire extinguisher on hand in case it's needed. Please note how the technician takes a moment to clear away all unnecessary tools and debris and remove any remaining plastic ties or snaps that may be located on the tubing to be brazed. Finally, make sure that there's a container of water and a wet rag available to cool down the parts once they're removed or installed. Now it's time to unsweat the old compression fitting if so equipped and discard it. It's important to use a new fitting that has not been previously tightened or damaged. Once the old fitting has been removed, clean the end of the tubing and the valve fitting with sand cloth. If there is not an excess of brazing material remaining on the tubing, it may be possible to slide the tubing into the valve fitting. However, as is the case here, sometimes this is not possible, even when the tubing and fitting are heated with the torch. In this instance, the tubing must be cut back beyond the excess brazing material to allow the fitting to slide over a properly sized tube until it's properly seated. After cutting the tubing, clean the end and fit the valve. Once the inlet tube is fitted, wrap the valve with a wet cloth and braze in the connection, making sure to keep the flame pointed away from the valve as much as possible. When completed, remove the wet cloth and inspect the connection to ensure that the solder has completely covered the joint with no pinholes visible. Depending on the fit, it may be easier to braze in the valve in one step, but care must be taken to keep all fittings seated as far into the connectors as possible. When it's time to braze in the connection to the distributor, follow the same procedure, ensuring that the valve is completely wet wrapped and the correct connection is secure in the valve fitting. It's very important to double check that any gaskets used in the fittings are removed before you start to braze the connections. Check the brazed connections for any remaining gaps or pinholes. If in doubt, re-braze the joint. After all of the brazing is completed, the external equalization line can be attached along with the distributor connection. Since the external equalization line is connected with a flare-type fitting and one already exists on the evaporator outlet line, it doesn't require brazing. Otherwise, it would have been installed during the brazing process. At this point, the technician has only hand-tightened the valve connections. Before tightening the valve connections further, close the unit door to make sure it will fit tightly over the new valve. Be sure that you don't forget to properly tighten the valve fittings before proceeding to evacuation procedure. The sensing bulb is now fitted using the supplied strap that comes with the TR6. The technician observes where the evaporator outlet tubes enter the header suction line. He then mounts the bulb midway up the tube to avoid impingement of refrigerant and oil on the tube surface where the bulb is making contact. Make sure the bulb is securely fastened and that it will not move around or along the tubing. It's a good idea to do a dry fit of the door panel to ensure that it will fit. It's better to do this now before everything is tightened and while the system is still dry. Once this is done, the external equalization line is tightened and the sensing bulb is insulated. This protects the bulb from the influence of the airstream temperature acting on it, which can cause the valve to overfeed as the airstream is warmer than the tubing temperature it's designed to sense. Now it's time to properly tighten all of the fittings on the valve. Do not forget to do this. Now this system can be evacuated to remove the air and other non-condensable gases that may be present. The system can also be pressurized with nitrogen prior to evacuation to aid in drying the system. It will also remove any moisture that's present. Now make sure the vacuum pump is connected using a good set of manifold gauges on both sides of the unit to ensure that you're drawing from either side of the compressor and TXV. This will ensure that you achieve a proper vacuum everywhere in the system. While the evacuation is underway, the technician should be monitoring the progress on the manifold gauges. He does one final check on the manifold gauges by closing the connection to the unit and comparing the vacuum with the pump alone in the system and notes any deflection. If this unit was open to the air for an extended length of time, and especially if it contained POE oil, it would be good practice to utilize a micron vacuum gauge to ascertain that a suitable vacuum has been obtained and that any moisture had been removed from the system. This would also be the requirement if the unit was equipped with a sight glass that was showing moisture was present by displaying a yellow indicator. In this instance, if the unit is tight and free of leaks, the addition of the dryer will remove any small amounts of moisture that may have entered the system during the brief time it was open. Once evacuation is completed and the system is deemed leak-free by a vacuum and pressure test holding after the pump was turned off for a suitable period of time, the pump is removed from the system and the technician prepares to charge it. He sets up a new jug of R22 on the weigh scale, makes sure the ammeter is clamped on, and does one last quick inspection of the system to make sure nothing has been missed. Now the technician will weigh in the refrigerant charge, while checking subcooling to ensure that the proper amount of refrigerant is added to the system. He does this by measuring the temperature of the liquid line and comparing it with the saturation temperature derived from a pressure temperature chart. If possible, you should always refer to the unit manufacturer's recommendation for subcooling values based on the measured indoor and outdoor condition. After the unit has been operating for a period of time, say a half hour, it's recommended that the superheat be checked to ensure that the TXV is operating properly. It's also good practice to note the operating conditions of the system as well as the inside and outdoor conditions for reference in the future in case they're needed. Once charging is complete, the technician may go back to the indoor unit to inspect the valve, connections, distributor and coil, etc. He's looking for any signs on the distributor tubing which may be frosted due to poor refrigerant flow caused by oil logging or other blockages. He can also look for leaks on the connections by feeling for oil, and if suspected, he'll use a soap solution to verify. Once this check is complete, he will replace the door cover and tighten it. For more information on how to measure subcooling and superheat, as well as a complete set of training modules for the AC and refrigeration technician, please visit Danfoss Learning online. It's a free educational website that offers a broad range of online training modules that can be done anytime you have free time. Danfoss also offers an app library of several practical tools for the refrigeration professional on the go, both for iPhones and Androids, including a refrigerant slider and handy pocket guide for troubleshooting on-site. Thank you for watching our program on expansion device replacement for residential air conditioning.